right, ladies and gentlemen, here we are at 9.5. We're wrapping up Unit 9, and we're going to just kind of piece together everything that we've talked about up to this point. So we started talking about variables, and we had an independent and a dependent variable, and with the dependent variable depends on what happens with my independent variable, right? Then we looked at how do we write that into an equation, how do we track that in a table. Now I have all my table, I can find my missing values. So I take my table then and I can put it into a graph, and this can help me find anything that might be missing along that same line, right? So I want to take it one step further, and today I want to bring back the equation to explain this table, or this graph, excuse me. So I have my variables. My variables go into equations. Equations can help me solve tables. Tables then get translated into graphs. They're all different ways of looking at my data. And now I want to come back to an equation, which is just one thing that will solve everything. So you might look at this as stepping back a little bit, but hopefully that'll make sense. What I want to keep an eye on is, this is a lesson on linear equations. Linear means line. A line equation. This is an equation that makes a line, a straight line. As you move forward with some of your data, you might see something that goes like this. It increases over time, right? Maybe this is Mr. W falling down a hill. Well, I'm going to start falling down the hill, and I'm going kind of fast, but as I keep falling, I'm picking up speed, faster and faster, faster, faster. That's not going to be a straight line. My linear equation will give me a set straight line, right? Now, we're talking about whales in this particular example, which is the first example in your book. And the whales swim at 3 miles per hour. I could go ahead and make myself a table that would look something like this. So this is hours and miles. And in 1 mile, it's 3 hours, 2 miles, 6 hours. In 3 miles, 9 hours, and 4, 12. So there's my data. I understand that, right? So my linear equation would be the distance that my whale is going to travel equals the rate that they're traveling at times how long they're traveling, or the time. Distance equals rate times time. In this particular case, I have a set rate. That's 3 miles per hour. So my distance equals 3 miles times however many hours that I'm traveling. So in this case, 3 miles times 1 is 3 miles. 3 miles times 2 equals 6 miles. 3 miles times 3 equals 9 miles. So this should give me a nice straight linear equation. It's just an equation that's going to produce a line. So if you looked at the last video we did, almost everything that we talked about was a linear equation. And that makes sense. We just hadn't named it that yet, right? All right, so if I take all of my information on my graph and I go 1 to 3, total distance that the whale is traveling, take my rate, which is 3 miles per hour, and I multiply it by the number of hours the whale's been traveling. If the whale speeds up and slows down, that's not going to be a linear equation. If the whale goes for 5 miles per hour for the first 2 hours and then 3 miles per hour for the next hour, that's going to change. That's not a linear equation. This is just a very simple equation that produces a straight line. 1 to 3. 1, 2, 3. You'll notice I don't have a 3 on my chart, so I do the best I can, going halfway between 2 and 4. This is not necessarily an exact science yet, but you really want to be close. Close you can be. 2 to 6. 3 to 9, which is halfway between 8 and 10. And 4 to 12. Now, let's say I'm tracking this whale over many, many, many hours, or days, or whatever, right? And it continues to swim. This is the Energizer Bunny of whales, and it just doesn't stop. So at that point, I get a straight line, straight-ish, because I'm freehanding this on the board. And I can understand that if the whale is traveling for 6 hours, let's check our data here. I go, well, how far is it going to travel in 6 hours? And you come up and go right across. 6 would be closer to 18. And again, you can see I've sloped off a bit there, but the information is pretty solid. So if I were to come up a little bit straighter, that would be a lot nicer right in through there. There's my straight line. Okay? So my linear equation with my straight line, there my 6 equates to 18, and that makes sense. Again, do your best to draw this. I'm drawing it freehand, so it does slope a little bit. but that's not our intention. All right, so linear equations are nothing too chaotic or fantastic. But if I were looking at another option right here and I want to graph the linear equation, that means that linear has the word line in it. It's going to be a line. If I had more information on this, I could put a title and then label each of my sections. I don't, so we're going to forgive that at this point. But please know, if you have the opportunity to put a title and different labels on it, you really, really need to. So y equals x minus 2. This is nothing special to us because we've done these types of graphs before. So x minus 2. If I substitute x as 2, 2 minus 2 is 0. If x is 4, 4 minus 2 is 2. If x is 6, 6 minus 2 is 4. And if x is 8, 8 minus 2 is 6. Now, if we were to think back to Unit 8 on this, or even Unit 7, substituting values for variables now to us just seems like habit. It's easy enough to do. But this is something we learned that was a new skill we picked up this year. That's kind of cool to see that it just flows for us, right? So substitute the value for x and solve the equation for y. So x being here's x, here's y. They stay the same in a coordinate plane here. X being my independent variable. I can change that all I want, and whatever I do to x, then that changes y. Y depends on whatever x is minus 2. Now I want to graph it. And my graph, to check my work, should be a line, because this is a linear equation. I've got 2 to 0. You do not always start at the origin point of 0, 0. 2 to 0. I've got 4 to 2. I've got 6 to 4. And I've got 8 to 6. Easiest thing in the world is a mistake to make is to flip those two. Make your x coordinate go on your y coordinate go on your x coordinate. Please just take your time and make sure that you're doing it correctly, and you can double check your work because you should have a straight line. Okay, so linear equation is just taking the equations that we have, and when I graph them, I end up with a straight line.